When y equals fx, we say that y is an explicit function of x. For example, y equals x to the power of 2 plus 3x minus ln of x. When f of xy equals g of xy, we say that y is an implicit function of x. Example, 3x to the power of 2 plus y equals 2xy plus cosine y. Please note that any function is also implicit, because fx is also fxy, but the opposite is not true. Pay attention. In explicit function, you have y on one side of the equation and x on the other side. In implicit, you have x and y's in both sides of the equation. Sometimes an implicit function can be expressed both ways. For example, x to the power of 2 plus y to the power of 2 equals 25 is implicit, because we have on one side xy. But it can be expressed also as y equals plus minus square root of 25 minus x to the power of 2, which is an explicit function of x. Example, sine of x to the power of 2y minus 1 equals e to the power of xy plus x cannot be expressed as explicit function of x. Finding derivatives of implicit functions. We will view x as a variable, but we will view y as a function of x, even if we have no idea what this function is. We are going to differentiate the x's as usual, but we will differentiate y's using the chain rule because y is a function of x. Please note, we also can view y as a variable and x as a non-function of y. The only reason I prefer this is because usually we grow up learning that y is a function of x. This is just a matter of what we are more used to. For example, if we differentiate fy, we will have to use the chain rule. So let's see. The inner function is y of x and the outer function is f. So we can take y of x to be the u and f of y is f of u. And that's why it is df over dy times dy over dx. And we have here two links, one for the outer function f and one for the inner function y. Here we will go over samples of several building blocks of implicit differentiation. We need to differentiate x with respect to x. d dx of x is 1. But d dx of y is dy dx. Because we're using the chain rule, it is 1 times dy dx. When you differentiate x to the power of 2 with respect to x, you get 2x. But if you differentiate y to the power of 2 with respect to x, it is 2y, the outer function, times dy dx. It's the derivative of the inner function, which is y. d dx of sine x is cosine x. What is going to be d dx of sine of y? It is a chain rule again, the outer function. You get cosine y. The inner function, dy dx. d dx of e to the x is e to the x. What is d dx of e to the y? It is e to the y times dy dx. It is really better to use here the Leibniz notation to remind ourselves that we are differentiating with respect to x. So if you take a function of x and you differentiate with respect to x, is exactly what you already know. But if you have a function of y's and you differentiate with respect to x, you have to use the chain rule. We are now going to learn how to find the derivative of y, which is, in this case, dy dx, when y is given implicitly. Example. We always have to work now with an equation. There are two sides to the equation, and we need to differentiate both sides. This is step 1, differentiating both sides. We know how to differentiate each one of the building blocks of the implicit differentiation, so let's use it. d dx of y to the 4 equals d dx of sine x. d dx of y to the 4, we have to use the chain rule, and we get 4y cubed dy dx. And d dx of sine x is the regular derivative, and we get cosine x. Because the goal is to find dy dx, we are now going to do step 2. We have to solve for dy dx. Because we differentiated everything, this is just algebra. In this case, dy dx equals cosine x over 4y cubed. Pay attention that the answer contains x and y. This is okay. Example. Sine x plus y cubed minus x equals 5. All the green ones are functions of x. I will take the constant also to be function of x because the derivative of a constant is just 0. And the other color, the pinkish color, is for the functions that has to do with y's. Step 1, let's differentiate everything. Again, we differentiate with respect to x, so it's d dx sine x plus d dx y cubed minus d dx of x equals d dx of 5. All the green ones are just non-directly, and the purple pinkish one will have to use the chain rule. And we get that. We are done with differentiating. So now we have to solve for dy dx. This is algebra. First we have 3y to the power of 2 dy dx equals 1 minus cosine x. Now we divide everything by 3y to the power of 2 and we get the answer. We are now going to combine implicit differentiation with other rules. We will start with combining implicit differentiation with the product rule. Xy to the power of 4 equals x plus 5. The gradient color is for expressions which are mixing x and y's. Step 1, we have to differentiate. We now have to use the product rule. Let's do the product rule. We differentiate the first, so we get d dx of x times the second, which is y to the power of 4. Plus, we differentiate the second, so it's d dx y to the 4 times the first, which is x, equals, on the other side of the equation, we have d dx of x, which is 1, and d dx of 5, which is 0. After we apply the product rule, we get a separation between the y's and the x. We have to differentiate d dx of x, which is 1, and we have to differentiate y to the 4 using the chain rule. We are going to get 4y to the power of 3 dy dx. And now we're going to put everything together. And we get 1 times y to the power of 4 plus 4y to the power of 3 dy dx times x equals 1. Now we need to solve for dy dx. One side of the equation, we are leaving the dy dx and everything that is multiplying that. And on the other side of the equation, we put all the rest, so it's 1 minus y to the power of 4. And now we just have to divide both sides by 4y cubed times x, and we get our answer. Now we are going to combine implicit differentiation with the quotient rule. Example: sin y over 5x plus 1 equals x. Step 1, we are going to differentiate. On the right side, we are going to get the dx of x, which is 1. On the left side, we have to apply the product rule. Differentiate the top one, which is sin y, times the bottom one, 5x plus 1, minus differentiate the 5x plus 1 times sinus y. All of this over 5x plus 1 to the power of 2. And this equals 1. When we apply the quotient rule, we get the separation between the x and the y's. And we know the building blocks, so we can apply that, and we get that. We finish with the differentiation. Now we have to solve for dy dx. This is algebra. We can multiply everything by 5x plus 1 to the power of 2 to get that. Now we have to separate between the product and everything that goes with the dy dx and all the rest by adding 5 sin y both sides. And now we're going to divide by everything that is multiplying the dy dx, and we get this.